Hi everyone, in this video we're going to be talking about the equation of a line. The equation of a line is written as y, our output, is equal to m, which is our slope, and the best way to think about this is like a roller coaster. A large positive slope means you're going upwards very fast, a slope of 0 you won't be going up or down, and a negative slope means you're going downwards. I just want to ensure that you understand slope is the change in y over the change in x, and these little triangles here are called deltas, which just means the change in. So this slope is multiplied by our input, which we typically write as x, plus b, which is the y-intercept, which is simply the value of y when x is equal to 0, essentially where our function hits the y-axis. Sometimes the y-intercept is not called b and some other variable is used. However, it doesn't matter and it will still mean the same thing, you're just using a different variable for the y-intercept. This can also be called slope-intercept form as well, which makes sense since we have a slope and an intercept, right? But what does this really tell us and why should we even care about it? First, we should notice that the equation of a line, is a linear equation. This means that it'll never bend or be anything other than a simple line. No matter what values you input for m, x, or b, the line will always be a simple straight line. Well, although simple, this little formula here is amazing. You could use it in determining the rate of change between 2 points on a graph, which tells us how quick we're increasing or decreasing in our output relative to our input. You could also use it to find, say, the length of a triangle, which we will be doing in future videos. There are many other applications as well. Let's do 2 quick examples here to ensure that you understand what I just taught you. If you're still confused, do not worry. In the next video, I will be solving even more examples and make sure that there is absolutely no confusion. So, let's say we were given the ordered pair, 3, 4, and we know that our y-intercept is located at positive 2. Assuming we know that this function is linear, what will the value of y be when x is equal to 6? Well, we first need to find our slope. We recognize this is needed as the 2 points, the one we were given and the one we are going to find, must be located on the same line because our function is linear. So, solving for m, the slope, we get 2 over 3. So just for further clarification, this means that for every step, every plus 1 in the x direction, our y value will increase by 2/3. Now, let's see if we're ready to solve for y at an x value of 6 yet. We begin by applying the equation of a line. We see here that all we are missing is our y value, and since we are only missing one value and we only have one equation, we can easily solve this. So we see that y is equal to 6 when x is equal to 6. Let's look at another question. What if we only had 2 points on our linear function? Our first ordered pair, point 1, is 2x, 4y, and the second ordered pair is 1x, 1y. Let's say we are told to find the y-intercept and the slope of this linear function. How do we go about this now? Well, remember what I said earlier about slope. It is the change in y over the change in x. So that means that m is going to equal the following. Think of this like the roller coaster again. The slope is going to be how much we rise, so our change in y, over the run, which is the distance in the x direction we travel. So once solving, we can see that the slope is equal to 3. This will give you the same answer if you said the points were switched, as you can see here. You achieve the same answer both ways. Now, how do we find the y-intercept? Since both our points go through the same y-intercept, and we have all other information, we can pick either point to use in the equation of a line to solve for b. I've done it both ways here just to prove to you that it is identical. Thank you for checking out the video. If you enjoyed, please like and subscribe to support the channel. However, if you have any comments, questions, or concerns about the information I provided in this video, please leave a comment down below and I will do my best to address your concerns.